Well, hello everyone. Thank you very much for having me. First of all, I want to thank Require Alex for this opportunity. This is going to be my first talk ever, so be gentle with me and be patient. And also, I would like to thank YLD for this opportunity. I hope that you like it. This is a topic that I really like because since I joined my company, I started working with the company, I had to start working with this kind of approach, with this subject, and this is something that is really interesting for me, and I hope it could be interesting for you as well. So let's get started. But before we start with the subject, I would like to introduce a little bit. Who am I? What are my passions? So basically, my name is Tiago Duarte. I'm a software engineer for almost 4 years now. I joined YLD about 2 years ago as a front-end engineer, and I currently work for a fintech company. I'm a full stack developer, but oriented more towards the front-end side. And like I said, I like to explore the bridge between technology and human interaction. That's what makes me really passionate about front-end, and that's why I adore doing it. And in my spare time, when I'm not coding, when I'm not trying to solve problems regarding front-end and UI and all of that, I like to work with I like to take some photography, and also I'm a really big fan of motorsport, potentially Formula 1. Go Ferrari, go Lewis Hamilton. So let's get started with the subject, which is about monorepos. But before we get into that, I would like to speak a little bit more about the standards. So why do we need source code repositories? So why we need it? Because we need to have somewhere else to store our code in a place that we can not only use it or access it or change it wherever we are. That's the first thing. The second thing is because we want to foster a really collaborative environment, so that if we need to work on a repository where you want more people to work, you want them to work with you, we need to have a space where they can deploy their solutions into the repository. And you always want to have a place in which you can organize all of your code, right? So let's think about what exactly does a common repository might contain, and think about that. Because I'm a more front-end engineer, I will try to present, or the examples that I'm going to present to you are more towards front-end than back-end. But I think it's going to be really easy for you to understand for those who work more with back-end or not. So I think it's going to be easy for you to understand. So what do we have? Mainly, a common repository focus on one single project. Mine contains source code, or it does contain source code, of course. It will have a dependency management system, some CI/CD work, and potentially some dependencies to external services or external libraries, okay? What exactly makes this kind of approach of single repositories, or as is academically known as polyrepos, the standard? So the first thing has to do with the fact that this kind of repositories provide you isolation, okay, and gives you the full control of whatever assets you have inside the repository. It gives you control of what the languages you want to have inside of that repository. It gives you the control of what are the libraries and the number of applications you might have inside of it, and as well who can contribute to the code or not, okay? So let's think about one scenario, which is, let's say that you work or just start working with a team in a certain company, and you are responsible for working or developing 3 types of applications. Doesn't matter exactly what those applications are, but let's just say that the common structure of that applications are, you have a web app. That web app has some dependencies, some libraries in which it depends on. Might be data models, mocks, an UI shareable package, or even an authorization layer. And just if you want to add another layer into the scenario, let's say that team B is responsible for a certain one of the packages, let's say the authorization layer. And adding to that, you also that web application communicates with a server, and that server will communicate with some APIs and make connections to some databases. Let's say that. And also, think about, or put that in mind, that all of the packages, all of the modules that compose the structure are always single repositories, okay? What exactly happens, let's say that you want to develop a feature in this scenario. And let's say that you have some order, some prioritization in terms of what models need to be developed first. So let's say that you need to develop the authorization layer. It doesn't matter what the feature are, first of all, but let's say that you want to make a change on the authorization layer, you need to make a change on the UI shareable package, and then, of course, because you made that change into dependencies of the React application, you need to also update the versions of that or of those dependencies inside of the React app. So exactly what happens? So of course you need to, if you're starting from the beginning, you need to clone your repository. After that, you need to install the dependencies. After that, as soon as you have the local environment set up, you need to create a branch, a feature branch. And then for, let's say, the authorization layer, and the UI shareable package, you need to refactor the code. And after that, this one in particular is only for the React application. Once this is done, you need to update the package versions, of course. You need to create a PR. You need to merge that PR with main, and then you need to delete the branch. Of course, this is already automated in some platforms, but this is what you need to do, okay? What is the catch? The catch is you need to do this too much times. You need to do 3 times because you have three different repositories, okay? Another example. Let's say that you as a developer, you realize that you found some piece of code inside of one of the repositories, and you figure out that, well, this is something that can be shareable. And I would like to put this into a really fancy package that can be used by everyone inside of my team or other teams inside of the company. So what do you need to do? Well, create a new repository. You need to copy-paste the code that you found that can be isolated and put it inside of that repository. You need to think about the name and version and think about versioning that package. You need to build CI/CD, of course, because you want to have automation and you want to do steps manually in order to make, to test the code that you want to isolate and to deploy and create the package and deploy it into some registry. Of course, you need to deploy the artifact. And then, after this, you need to, again, delete all the code that you isolated and replace the dependencies, or replace the imports and the references on all of the other projects that might take advantage of this isolation, okay? So I'm not sure if you already realize, but in order to do this, in order to do all of these tasks, you start to realize that this adds a bit of overhead. Why is that? Not because you need to focus, not only you need to focus on the main task, which is develop the feature or isolate the code, but also because you need to carry about all of the other things that are implied, DevOps or whatever. So basically, do project management kind of tasks and all of the DevOps operations that are attached to it. What are other issues that might be implied that are associated with Monorepos? So you might have cumbersome code sharing. You have complex cross-repo changes, because if you need to do one change on one side of the repository, you might need to, and if you have dependencies between those repositories, you might need to also do the changes on other sides. You have PR madness, or as I like to call it, PRT. Joke doesn't work. And yeah, so basically you have PRs all over the place. You need to wait for those PRs to be approved. You can see that there's tons and tons of things that are really unnecessary. And just to finish this, you also have inconsistent tooling. Why is that? Because you might have, for example, you have a CI/CD pipeline that might be completely different, might have a different strategy to one repository to another. And you might, for example, inherit repositories from other teams that might have completely different philosophies, okay? Another problem that it's attached to polyrepos, it's called dependency diamond. So I'm not sure if you guys are familiar with this phenomena, but this is really common with polyrepos. And this is basically just to give you a quick summary of what this is basically the problem where you have a certain project, let's say project A, that depends on another package or project called B and C, and those have a common third-party dependency. The main difference is one of the projects depends on one version of the package D, and the other one depends on the second version of the package D. What this might bring? Well, might bring you version conflicts. And what happens with version conflicts? Well, you might have unexpected behaviors when you bundle all of that and you try to run your application. You might have incompatibility issues and all of that. And in some occasions, package managers, what they try to do is they try to do one of two things. Or they try to use multiple versions, and this, of course, can increase bundle size and potential inconsistencies. Or they can try to use one single version of the packages and pray and see if everything works. What would be really easy, or what would be really ideal to do is, what if we try to solve this just by, instead of having this problem, what if project B and project C depend on the same version of package D? And there comes Monorepos, one repository to control them all. So if you think about it, about the scenario that I just presented to you, you can see that basically, if you think about the structure from the beginning, you have three applications with mostly this kind of structure. You might have a server, libraries, and all of that. And what Monorepos try to propose is, what about having one repository that have all of these applications in one place? And that's basically what it does. So what you can see in terms of differences between one to the other is that instead of having your source code from the root level of the repository, you just have like a package folder in which that package folder might contain all of your modules, all of your applications, packages, whatever. App 1, App 3, all of that, okay? So what exactly is the definition of a monorepo? So monorepo or monolithic repository, it's basically a single repository that holds several projects. Those projects can be related or unrelated. Personally, I think that they should have some contextual relationship. So the packages that compose that monorepo, I believe it should have some context, because if you don't have any context, you might fall into the trap of, let's just dump whatever repositories or whatever packages I want to put here. And when that happens, you have what they describe here, or what I could find in terms of categorizations between types of monorepos. You have these two kinds of categories, which are project monorepos, which I believe are the monorepos just for common mortals like us, that is manageable, but just like with one developer or a small set of developers. And then you have what it's called monstrous monorepos, which basically everything that you want to put inside of your, let's say, company or project, let's say, you want to put it inside of all of that and in one single repository. And this is a common strategy that Google, Facebook, and Uber, use it. So, what exactly are the advantages of monorepos? So, to start, you have standardization. Why is that? Because if you think about it, now, because you have all of the packages, all of the projects inside one single repository, you can create generic pipeline work, or can create generic scripting or tools that can benefit and be used by all of the applications. So you don't need to worry about having different kinds of pipelines for all of the packages and all of the projects. It's one single thing for all of them. And this provides standardization, for example. Second thing is visibility. Why? Because now we have one single repository in which all of the applications live in, and so whatever devs need to work with this repository, they have everything inside of that repository, and they can visualize everything, and gives you the possibility to not have to have silos inside a project, inside a team, let's say. The other one has to do with synchronization. This is something I'm going to talk a little bit more in the next slide. And then you have centralization because, of course, you have all the packages in one single repository. What other benefits might bring to you? Modularity. Why? Because you are able to have all the applications you have there can be identified as single modules in the sense that, and I try to put this on the chart on this representation here. If you look into the way that the applications are structured, you have everything built in such a way that if you need to, let's say, remove one module and bring that into another team, hand over that into another team, that is possible. And it's just as simple as grabbing that application, putting that into a repository, and that's it. You don't need to worry that much about other stuff. What else? Simplifies the dependency graph because now if you have common dependencies between all of the apps, all of the applications, you don't need to have repetition, you don't have to have duplication. You can just basically have one version of that dependency that can be used across all of the others. So, and this will reduce also the bundle. What else? You might have better organization, and then you have better coordination within the teams that might work with this structure. Speaking about synchronization, why is that possible? Well, this is possible because one development strategy that is called trunk-based model. I'm not sure if you guys are aware of it and how that works, but basically what it is different from other kinds of strategies because you tend to force all of the devs to work or to commit all of their changes into the main or trunk branch. And also, it's really useful or try to imply a policy of having short-lived branches. So this helps you to not have to have like really long feature branches that stay for so many times, for so long, for such amount of time into the development process, which might cause merge conflicts, for example. And in order for you to have that, the benefits of having these short-lived branches forces the devs to make comments quite frequently. By having that, it helps the continuous integration of a project because forces the unit tests to be the testing associated with the project to be continuously being executed. Also, it prevents or allows for you to find bugs more easily so that you don't need to deploy or you don't fall into the trap or accidentally deploy bugs into production. So it's safer. And also, because of that, it enhances stability and the quality of your code. So, if you think about what I've just showed to you, let's try to recap the scenarios that I showed you before about developing a feature and sharing reusable code. So a reusable code. So what we need to do to develop a feature. So right now we just need to do this. It's more or less the same, apart from you just need to do it once. You need to clone a repository, install the dependencies, create a branch. All of the work that it's implied with the task, which is update the dependencies and refactor the code, can be done in the same place. You create a PR, you merge into main, and you delete the branch. That's it. And what about sharing reusable code? Well, that easy. So what you need to do is basically create a new folder inside of your repository, move whatever code you want to isolate it into that place, and potentially the IDE that you're using will resolve all the dependencies, all the imports for you, and that's basically it. Let me just check what's happening here. Okay, it's available. Cool. I'm not going to do anything. Any questions? Any issues so far? Can I continue? Nice. So let's say that I was able to sell this approach to you quite well, and then you think, well, I want to start using Monorepos right now. How can I do this? Well, for me, I believe there are three main things that you need to be worried about, and you need to understand how those things work. First of all, has to do with package management. How does this is done? This is done inside of a monorepo. Second thing has to do with task running processes, and the third one has to do with scaling. Let's start with the package management. So let's say that you're now in a place where you want to put all of your applications of your project inside of this repository. Well, it would be ideal if we could figure out or resolve the dependencies in such a way that not only once I try to install those dependencies in order for me to start working with the project, I have to have duplications of all of the dependencies. And also, because we need to be aware that in spite of having the projects in one single repository, we always want to make sure that the usage of those dependencies in the projects that incorporate that monorepo are made in such a way that it's not basically just referencing local references of those packages inside of the repository. So let's say that you want to take advantage, like what I say here, so not have duplicated dependencies over to the code base, but also treat the dependencies as if they were being pointed to a version from the registry, let's say. So one way of doing that, and this is something that package managers already provide to you, is what it's called the workspaces protocol. So this was something that was introduced with Yarn at the first place, but now common package managers like PNPM or NPM already provide this. And basically what they try to do is they find the dependencies and they fetch the dependencies once, and then they use symbolic linking for you so that you don't need to install those dependencies twice inside of the repository. Basically, that's how things are done. And this is the way that the package management systems try to handle the dependencies inside of a project, let's say. What about task running processes? So now, again, you have projects or many projects inside of this repository, but you face a situation where you don't want to have for every single build, every single install, every single lint type check test command that you want to do. You don't want to have to do this for every single project that you need to work with. Well, I would like to take the advantage of managing command executions and possibly have a way to make some recognition of the projects that I have inside of the monorepo in order to find a better way to orchestrate those tasks. So Lerna, not sure if you guys know what Lerna is, but basically Lerna was the first tool that initially introduced all of these features. But the problem is it's really hard to, or it's really cumbersome to try to apply those configurations in that platform, in that tool. Nowadays, you have really interesting tools that provide you all of the features, or basically some of really handy features that I'm going to present to you next. So you have all of these tools. So the first one is NX, the other one is Turborepo, Bazel, Lag, and Moon. So I'm not going to make a comparison between all of them. What I'm just going to do is speak about what all have in common, but I just thought it could be easy for you to just have some references to the tools. So if you're interested about using those tools, you can easily just search for them, and I'm sure that he will give you some proper documentation to how to start using those tools. So what those tools have in common that are really handy for you to work inside of a monorepo. So first of all, you have incremental adoption. So you don't need to take full advantage of the tools if you're not ready to use them. So you can incrementally adopt the tools. It provides you task coordination, which is really handy, and something I didn't told you before. I'm using as a demo. I'm using Turborepo just for you to have some visual cue or visual representation of what I'm trying to explain here. But provides you task coordination, so gives you an opportunity to run the commands in such a way that if you have dependencies within packages, let's say they have a React application and that React application has a dependency with an UI package, of course that if you want to run the React application, you want to make sure that the package from the UI shareable component or the UI shareable package, it's built first. So the task coordination is a feature that is provided by those tools. So it allows you to do that. And as an example, what I tried to show you here is basically an example where you have many modules, and as you can see, all of those modules are being executed at the same time, and some of them already finished, for example. The other thing is local computation caching. So it allows you to not only run things in parallel, but if you want to run them twice, or more than once, let's say, you already have caching, so you don't need to, or the time that will take for things to be executed will be really short. So on this example, what I'm showing you is I'm running a build command once. As you can see, there are 6 tasks that are executed. Nothing is cached. It takes you around 9 seconds to execute. But once you do it again, because everything is cached and no changes were made, it will identify that, and of course, the operation will take like 207 milliseconds, from seconds to milliseconds, which is really amazing. The other thing is basically the same thing, but instead of being pointed to a local environment, is more towards a distributed environment. So let's say that you want to run your CI/CD pipeline, and you want to run it on a monorepo. You can have, for example, you can build the packages, cache them, and they can be available to CI agents, so that once they need to use whatever artifacts, they don't need to build it anymore because everything is already cached. Another thing really handy has to do with workspace analysis. So basically, those kinds of tools are really handy if to make like a comprehensive analysis of what you have inside of the repository, figure out what the dependencies are, and give you a really nice graph about what are the dependencies. So this gives you more visibility. And another thing that I would like to show to you, and this comes a little bit associated with what if inside of this monorepo, this is not just one team using it, but you have like more teams using it, and you have more, the size of this monorepo is a little bit bigger. Because you have this, let's say like, you don't have rules inside of a monorepo in the sense that if you want to easily use one dependency or one package into another, you can easily, in theory, you can easily just make an import. However, in some places, in order for you to incorporate some rules, some tools like NX, for example, offer you this modular boundary rules, which is basically some configuration that allows you to say, well, for this particular package, I don't want this package to be imported by package A or package C or whatever, which is also really interesting. And that's basically it in terms of tooling. And now comes the problem of scaling. So this is really interesting. The monorepo approach is really interesting if you're thinking, or if you're working with a project that might have like 1, 2, 3, 10 applications, but let's say, or packages. But let's say that your monorepo scales. Instead of having like 10 projects, you have like 100 projects. Well, you can, or in terms of development feedback, development workflow, you will have or basically your development workflow will be affected by 3 main things. First of all, it has to do with space, because it will not be that easy to just clone a repository that instead of having like 5 gigs might have like 50 gigs or 500 gigs, for example. Another one might have to do with time, because not only you can't, or it's impossible or almost impossible for you to download that amount of a repository, but also it will take too much time. But also it will affect your cognitive effort, because in order for you to try to search on that on such a big repository is really hard to do. And even the common tools that offer you search capabilities might have some difficulties in order to give you the results you need. And this is a really interesting metric that I thought would be interesting to show you guys, that has to do with what are the metrics that seem to start when you have this kind of metrics, this is where monorepos, the scaling of a monorepo starts to become an issue. So for example, if you have inside of a monorepo, if you have 10 to 100 developers writing code full time inside of that repository, if you have 10 to 100 projects in progress at the same time, if you have 1K to 10K version dependencies, or if you have 1 million to 10 million lines of code, that's when things start to become difficult for you to develop in your local environment, let's say. And also at the same time, because you start to have, your project starts to scale, when that happens, usually at the same time, it's because your company, your project, whatever, also starts to scale and start to become big. And when that happens, sometimes you have investment, or you have capabilities to basically invest in your own tooling. So you can invest in tooling to solve problems like file system, for example. You can, and basically, let me just check. Yeah, custom tooling to help them mitigate the side effects. The first thing has to do with virtual file systems, and then another possible solution that those companies might try to solve or might try to tackle is try to provide tools like search as a service tools, which is basically more complex tools that offer you capabilities to search on those kinds of big repositories. And one clear example of that is Google. So Google is, if you don't know, Google is one of the companies that has the most famous monorepo in the world. All of its code base, it sits inside of one single repository that is used by 20K developers, and they have invested really hard in tooling to help them mitigate the problem of scaling. Well, what are the concerns about monorepos? So, first of all, it has to do with complexity, because, of course, you might have all of these projects inside of one repository, but this adds complexity into the code. You might have tooling overhead, because you need to think about creating tools specific to solve problems for a particular monorepo, and that brings overhead, of course. Also, you have over-engineering, trying to find solutions to solve the basic structure, the common, let's say the real problem, or the real core of what this problem, what this approach is, which is having many packages inside of one repository. And then you might have build and test plots and deploy problems. So if I tried, or if I was able to explain you this well, or well enough, you start to realize that the technical arguments, there are no technical arguments to decide between what if you want to use a polyrepo approach or if you want to use a monorepo approach. And companies have suffered really hard in how to find arguments to determine whether I should use one approach or the other. And because they don't have technical arguments to figure that out, they need to jump and start thinking about other kinds of problems. And that's when they turn towards the philosophy of the company and the culture of the company. So basically, they figured out that in order for you to determine whether if you want to go for a monorepo or a polyrepo, you need to start thinking about what is the culture of the company, how the company works, how the developers work inside of that company, inside of those teams. If they want to have like a more collaborative environment, or if they have silos within the company, or if they want to have, for example, projects or companies that focus on one single project, let's say. And I believe that the best example that I can give you is between those two companies, Google and Amazon. So two completely different companies of the tech industry. one follows the monorepo approach and the other one follows the polyrepo approach. But both have completely different cultures. For example, Google has a culture where there's, like I told you, has open collaboration, shared ownership, visibility of the code. So basically everyone can try to access or search for whatever they want inside of that big monorepo. But as opposed to Amazon, Amazon tried to emphasize more on the autonomy, having rules like, for example, the two-piece rule, which is having teams or small teams that are responsible for one single microservice or repository. And because of that, and also because of what the teams or what the companies try to have, you can see that Google offers or tries to reach a more holistic team cognition, which is basically trying to have all of the, let's say, experience and all of the expertise of the team members integrated. So let's say that I work for a team inside of Google that everyone has like different backgrounds, everyone has different perspectives of and expertise inside of that team. By having like a more holistic kind of team cognition, they try to bring all that together and put every single developer inside of the same level so that they all can be at the same pace, let's say. And again, team members align their knowledge and actions towards common goals. And in order for them to tear down the silos within the company, they think that that's why they want to try to reach or try to use monorepos. But with Amazon, the thing is it's completely different. So they tried, instead of using like a more holistic team cognition, they try to go towards a more collective team cognition, which is set of individuals have their own expertise, it's not shared, and there is less integration and shared understanding about this. So, any questions, any doubts so far? No? So that's the end of the presentation. Thank you very much. I hope this was interesting for you. So thank you.
I do have one question. Do you consider the Linux repository monorepo or?
It is not, actually. I searched about this. So the Linux system, they don't use monorepos. They use a polyrepo approach. I'm not sure exactly why they do it.
I think it is one repository.
I'm not sure exactly, but I have this. I'm positive that I'm 100% sure that I found it to be a polyrepo, but I might be wrong. But let's say, for example, that
the reason that I asked is because, well, it lives under a single repository, but it's just one project.
Right. Okay.
So maybe it's not considered a...
Yeah, I mean, this is something that I didn't talk about because didn't serve my purpose. But basically, when you are dealing with monorepos, you can deal in two different ways. You can go for a more modular kind of approach, which was what I tried to show you here, which is you have different packages that behave like modules in which they can all work together inside of one repository. But if you need to, for example, put that into a single repository or hand over to it, you can do it quite easily. But then there is another approach, which is the more integrated kind of approach, where you don't have modules. Everything is interpreted as one single project, and yeah, so it's more difficult for you if you want to extrapolate that, put it into a single repository. You can't. It's more difficult to do. And maybe that's the example from Linux. Linux, they have a monorepo, but they use the integrated approach instead of using the more modular approach. Not sure if that answers your question.
Yeah. Thank you.
Thank you.
Any other questions?
Hi.
So monorepos obviously have a lot of benefits. But what you mentioned about it kind of spreads the ownership. Is there any tool, any process to set some boundaries, set some ownership, but still use the benefit of monorepos?
Yeah, so in terms of ownership, I can try to give you my personal example. So I use monorepos on the company that I work with, on the team that I work with, and of course, let's say that, for example, if you think about monstrous monorepos, that's a problem, because usually when you have that kind of repositories, it's not like one team working on it, and in that particular situation, I believe that you don't have any ownership. So you might try to have, for example, when I show you the feature, the modular boundary rules, that is a way to achieve that ownership, in the sense that you want to say that for a certain project or a certain module, that module cannot be imported in some way by other teams. That might give you a little bit of ownership. But on my particular case, I personally find more useful of using monorepos in a more project kind of environment, like small project kind of environment, because you can control all of the modules inside of it. And yeah, that's basically it. I'm not sure if that answers your question.
Thank you.
You're welcome.
Does anyone?
Hi.
Yes. Hi.
About permissions in a repo, for example, when you want specific teams or given developers to have specific access, take, for example, GitHub. In a monorepo, how would you be able to do it? By giving a specific path, but I don't think it's possible.
I think it's more related to what are the intrinsic properties of a monorepo, because the intention of having a monorepo is for you to have this workspace where you have all of your projects, but I'm not exactly sure how you do it, because fortunately or unfortunately, I'm not sure. I would say fortunately, I did not have to work with in such an environment where you need to have so many teams working on the same repository. I was trying to give you my example before. So basically what I do is it's basically the example that I showed you in the beginning. So I work for a company that I'm developing 3 applications. The 3 applications have things in common, and because they have this, what I told you in the beginning, this contextual relationship. So packages that have some connection with each other, I found it more useful to put that into a single project. And that's why, because it's only one team responsible for it, it's easier. But when it comes to more teams, maybe I'm not exactly sure how you do it via GitHub.
Probably could use the code owners and
yeah.
teams.
Yes.
Or this folder belongs to this team.
Yeah, that might be a solution.
Yeah,
Yes.
but that doesn't stop any developers to just mess with the code. If you have an insider, for example.
Yeah,
on the security point of view, I mean.
Exactly. That might in that situation, probably what needs to be done is what I tried to show, which is try to invest in tooling. Try to find, for example, scripts or to create scripts on let's say GitHub Actions, in which you can evaluate by the author that is making a commit, can try to identify if that user is from a certain team, and if it doesn't correspond, then it's not at all, you're not allowed to create a PR and merge that, for example.
So one solution create other problems.
Yeah.
Yeah.
Yeah. Always like that.
And I had also one question about CI/CD. For example, when I want to, if we split microservices, like we spoke before, if you want to deploy, build Docker images, for example, OCI images. How would that work with monorepos? By adding more workflows?
No, that's the thing. Because you have this environment where you have all of those packages inside of the repository, you have the possibility to create a more generic kind of a workflow that works for all of the modules. So you can create, for example, that's what we try to do in my project. We try to create this workflow in which we can reuse or try to create all of the packages that we need for a certain purpose and put all of that together, or try to do that together in that workflow. So yeah, you don't need to worry about that. Should not be a problem once you have that approach. I'm not sure if that answers.
And you deploy, when you split into application A, B, C, you will have 3 different images, for example.
Right.
All right.
Yeah.
Hi, great talk, by the way.
Thank you very much.
Yeah. My question is, with the rise of AI and, this AI programming, AI agents, LLM, whatever you call them, do you think it's better to code in Monorepo now because you have AI that can understand everything in one place?
Yeah. Personally, thank you thank you for asking me that question, because when I start working, thinking about a subject for this, a subject for the talk, and when I thought about Monorepos, that was one of the first things that I thought about AI, because if you think about it, most of the problems that are right now attached with Monorepos, like for example, if you think about the tools right now that exist to help you with Monorepos, if you have AI agents that might help you identify potential, let's say, solve the dependency graph, for example, might give you more quick tools or quick handy hints for you to help you optimize your structure of the Monorepo and therefore bring you more performance, for example. So I will say that yes, AI might bring you more advantages, and because of that, I believe that will help more the usage of Monorepos rather than polyrepos, I believe. Not sure if that answers the question.
Yeah, it does, yeah.
Thank you.
Brilliant talk. Well done.
Thank you
For your first one.
Thank
Amazing.
you. Thank
Well
you very
done.
much.
Very thorough with all the information. This is a topic that I'm very passionate about because I use it on my daily job.
Nice.
And I just want to poke a little bit into the scalability issues on the Monorepos. Yeah, because until that slide, I was thinking that your presentation was missing, and then it became complete for me, at least. I just want to share some thoughts because I've been there, and I don't agree with the 10 to 100 developers because it doesn't depend only on the developers, it depends on the amount of work that they're doing, especially with what you said on the trunk-based development.
Right.
You get into a deadlock really quick. Like you're rebasing, someone else creates some pull request, you're rebasing again, another pull request, and you're fighting against each other. And this can happen with 5 devs if you're doing really quick pull requests, as you should.
Exactly.
So I just wanted to put this out there because this has been my experience, and I don't know if you came across the same, but on this particular point, Monorepos are dangerous.
Yeah, that's the problem. Personally, I didn't have that experience, but I can recognize that might happen. Yes, if you have that, let's say, competition, like having like all of those merges with the trunk, not only you're also like spending too much resources to run the pipeline and run all the tests. And to run the test, that is something that's something that I have personally experienced. It's really, really hard for you to have everything like run at the same time, let's say. So yeah, I can relate with that.
Because you revise, then CI kicks again, tests run, you constantly work. Anyway, it's cool to discuss these. Second, I promise I'm going to make a question.
Sure.
Have you experienced? Have you tried NPM workspaces instead of turbo thing?
No, actually, that's the when I start working with Monorepos, the first thing was the first tool that I experienced was Turbo Repo. I've never used another one, but if I don't misunderstand, NPM workspaces is another way for you. It's like a more, I would say, more like simple solution, more basic solution, because it doesn't offer you the same level of tooling, same level of features that you might have with those kinds of tools.
Yeah. So I was hoping your answer would be yes, because then I would ask what were the advantages of turbo thingy, because I'm having a problem right now where my UI shared lib that we have in a package, we cannot publish it via like on NPM public registry and have it at the same time on the Monorepo accessible without building. Whilst NPM, when you start workspaces, it allows you to consume files without building.
Right.
And Turbo Repo like builds automatically, like you said. So that's going to be the solution that I was trying to avoid going into. So hopefully you'd have some insight, but thank you.
Apologies.
No worries. Cheers.
any more?
Well done.
Thank you very much. So I don't think there's any more questions. So if not, thank you very much for the opportunity.